Hello and welcome to my second presentation showing the different updates for my major final project for my master's titled Financial Charts Data Extraction and Report Generation via Computer Vision. In order to show you all the different updates that have happened since the last time I have presented, I have divided the different updates into 6 different steps. Firstly, I have finalized the project research. As mentioned in my last presentation, one of the next objectives, one of the more important ones, was to finalize the computer vision research that has been done on chart data extraction in order to know exactly what to focus on my project. And because of that, I have defined the scope of the project. And now the new project, as you most probably noticed from the title, is the fact that I will be focusing on extracting data primarily from financial charts instead of all different types of charts. So I'm talking primarily about time series charts. And moreover, I will be also working on creating automatic report generation based on the data from the charts. So I'll be creating a database and also the report itself, which will provide different insights taken from that data. As the third point, I have defined the top 5 price websites. So I checked the most used websites to create data sets for the charts. People that check these websites usually go there in order to check all different prices for different cryptocurrencies. This project will focus on that, although the work itself can be applied to any type of stock price chart. And in the future, this top 5 may be changed to top 10, depending on how accurate I can get the algorithm to work in order to recognize all these different types of charts. For the fourth point, I have created a virtual environment in order to create a reproducible analytical pipeline. And this has been done through the Anaconda Python virtual environment, where I have assessed all different libraries that were needed and their dependencies and installed them based on the correct versioning, as all the different libraries require different types of versions. So for example, TensorFlow 2.10, which is the latest version that works on a Windows machine that can also use GPU power through CUDA, also requires a certain version of CUDA, which is 11.2. And then it also requires NumPy, which has to be version 21, if I remember correctly. So there are many different types of libraries that require specific dependencies on specific versions of libraries. And then finally, I tested the environment and the code to make sure that my resources on my workstation are available and they can be used and that all the libraries are working correctly. So now I'm just gonna go one by one through all of these different 6 points that I've just discussed. So firstly, as I mentioned before, in terms of the existing work, there is not much research in this field, in the field of using computer vision to extract data from charts, as it is quite a complex problem. But there are many different levels of accuracy for the different projects that are available, from as low as 20% to as high as 97%. So some of them are chart OCR, chart reader. Some researchers have used faster RCNN in order to extract this data, and there are many other solutions that mostly use deep learning or some form of trained convolutional neural network in order to extract this data. And my initial concern was of recreating work that has been done by dozens of researchers that have worked for a longer period of time on this project, and they have worked as a team, so they had higher resources, and I don't want to recreate something that already exists, and especially to recreate it with low performance. So in my case, what I can do is I can focus my work on one domain, which in my case would be the financial chart type, and try to get high results on that, and then compare the results and the performance of my research and my project with the existing solutions that are for a general purpose, so for many different types of charts. So I'll most probably be comparing my work with something like chart OCR or chart reader. And then finally, the work that I will be using is open source, and my work will also be available on GitHub as open source. For the second point, defining the scope of the project, one of the biggest parts of the project is that I do not want to use deep learning like everyone else is using in most of these researches. That I've found is that I want to use a robust computer vision algorithm so that I can extract all the information through all the different functions and the mathematics behind computer vision. So I'll be using deep learning as well, but only to detect where the template, where the chart is within the frame itself. And then everything else will be done through computer vision. And the idea is to also have a report that's automatically generated with the insights. So the idea is that it will be able to offer information such as in the last 24 hours, the lowest price has been reduced by this amount compared to yesterday, and this is the value. The highest point today is this, which is, I don't know, 5% higher than what was present 2 days ago or yesterday. This is the type of information that I'm looking to present with my automatic report generation. And finally, I'm expecting a quite performant algorithm because it will be, as I mentioned, mostly done in computer vision with very little and limited deep learning usage. And I will be comparing my performance with other solutions available on the market. Finally, the top 5 most used websites for crypto price checking, according to different sources online, are Binance, Coinbase, CoinDesk, CoinMarketCap, and Crypto.com. And there are different chart of types. So all of them are time series, which is what is usually used for this kind of stock price visualization. And we can see here that all the 5 different charts, they are similar, but they do have variation. So my algorithm will have to pretty much be made in order to work with all of these different websites with high accuracy, and to pretty much keep in mind that there are different little variations here and there. So for example, some charts may have the different lines limiting different sectors and different values. Some other charts do not have them, and there are also different colors used throughout the chart. The formatting of the X and Y axis are also different. Sometimes the Y axis is on the right side. So what I'll be doing is I'll most probably, as I mentioned, use the deep learning aspect to identify where the chart is and identify if the different elements are on the left side or right side, and see how that then gets translated into computer vision information that then can be used to those algorithms created within OpenCV to extract all the different values that I want. Finally, the virtual environment was created in Anaconda, as mentioned. All the different libraries can be seen on the left side with their exact versioning that has been used. The development will be done in Spider. And for visualization, I'll be using Seaborn mostly. And then for 3D visualization and for interactive visualization, I'll be using Plotly. Then, as my last point, I assessed the virtual environment to see that I actually have access to my components in my workstation in order to use that power to be able to train a higher amount of deep learning models in order to improve the accuracy and reach a higher level. And then also to have library functionality so that I can actually access all the different functions that I will need and require throughout this project. And as can be seen in this in these 2 screenshots here, I do have access to both my CPU and my GPU for training and testing deep learning models, and also for using OpenCV. Both can be used with CUDA within a virtual environment. And then I also have access to 100% of this power and the 24 gigabytes of VRAM of my dedicated GPU. And as the last thing, as I mentioned, because of the open source aspect of it, I have a GitHub repository, and all my information and all the work will be available on this GitHub repository from now onwards. And I'll be continuing to work on this project and have weekly commits to this. And with all this said, I would like to thank you for the time dedicated.